Okay, in this little section we're having a look at families of polynomials which can be expressed as the product of linear factors. Now, it's almost going the other way around, so what they're given is the actual graph of the polynomial, and we need to work out what the formula is, or what the equation is. So what does y equal? Well, we do that by looking at the linear factors. So generally we get y equals x plus 2, x take 3, or something like that. And then to find where the x-intercepts are, we solve that for 0. So x plus 2 equals 0, so x equals minus 2. X take 3 equals 0, so x equals 3. Okay, just a little tangent, just as a brief overview. So what we're doing is we're going to go the other way around. So we'd use those points to put on the graph. Now we're given those points and we need to put it back into this. So that's what we're trying to do. So starting with a general equation, okay, we can say x take x1, x take x2, okay, and that's just going to keep going depending on how many factors we have. For this example, we've got 1, 2, 3. Except this one, if you remember, it touches the x-axis, so it's a repeated factor. So we actually have 1, 2, 3, and 4. So putting them into our equation, we can say x take our first point, which is 3. So doing the opposite of it, x plus 3. This one, x take 2, and it's a repeated factor, so I'll write it as x take 2 again. And then our last point at 5, so x take 5. So there are our 4 factors. Just a bit of a tidy up, I can say x plus 3, x plus 5, and x take 2, and that's going to be squared because I've got 2 of them. So that's all we're doing. That's the easiest way to do it, is look at your x-intercepts, your factors, and put them into linear factors. Okay, so just looking at the factors, and what we want to do is just look and see what they actually do. So x plus 3 indicates that it's going to cut the x-axis at, so cuts at minus 3. So cuts it, okay, from starting up and going down, nothing else happens there. Same with this one, x plus 5, so it cuts it at, that should be minus 5, and should be cuts it at 5, so that's all we're doing. We cross it at 5. But this point here, x take 2, what does it do? Well, it's a repeated point, so it touches it too, okay? Just touches it, then goes back down again. Whereas these ones, they go through it. They cut it, almost. Okay, so what we want to do from that is to make a bit of a summary. So we've got y equals x take a, x take b squared, x take c cubed, and x take d. So what are we looking at? Well, the cuts the x-axis at a, so let's cuts it at a. Doesn't matter what number a is, it's just going to cut it. So in this case we had minus 3 and 5, so goes across it. Okay, when we get a square, it touches it. Touches at b. Now I didn't have a cubic part in this example, but if we have power of 3, we did have a look at that in cubics, and that's when we had the stationary point of inflection. So what we can say is it saddle cuts, bit of a fancy name, at x equals c, okay, stationary point of inflection. So that thing. And for the last part, again, cuts it at D. So just a bit of a summary. Okay, powers of 2 touches, powers of 3 saddle cuts it. Or actually, what we should say is even powers touch it, and odd powers are going to follow that shape. Okay, just finishing off that little bit there. So we've got a set of axes. I'm just going to show what it means. So we've got A, B, C, and D. So point A cuts it. So we go across it. Point B, it touches it. So if we start from the bottom and go up, and going to touch it and then go back up again. C, we're going to saddle cut it. So we go down and something like that. And then point D, we're just going to go straight back through it. Okay, I'll leave this video here and I'll do an example in a moment.